Today we're going to start by talking about maximum versus minimums. The maximum point of a function is the highest point on the graph. The minimum point of a function is the lowest point on the graph. Not all graphs will have a maximum or a minimum point, and a maximum or a minimum point occurs when the graph changes from increasing to decreasing or vice versa. And we're going to look at this in example 1. Example 1 says determine whether the graph has a maximum point, a minimum point, or neither. If it has a maximum or minimum point, then name the point. So if we take a look at letter A, we are looking for a maximum or minimum point. So that's going to occur when the graph changes from increasing to decreasing. So that means as we go up, we are never changing. So this is increasing from left to right, and it never changes, which means there's no maximum or minimum point. There's at no point that we switch directions, going here to here, or vice versa. So letter A, our line does not have a maximum point or a minimum point. So here we would say neither. In letter B, if we take a look, we are starting from the left to the right. As we go up from the left, we're increasing our function. And then we get to a point, and then we start decreasing our function and going down. So we went from increasing to decreasing. So where it changes will be our maximum or minimum point. Since this is on the top, it's the highest point of our graph. This is a maximum point. So we can say that this is a maximum at the point, and look at your ordered pair, 2, 3. And then let's take a look at letter C. Again, from left to right, if we look at our graph, we're increasing slightly, and then we start to increase a little bit more, but we are continually increasing the entire time. At no point does our exponential function change from increasing to decreasing or vice versa. So we could say for letter C that this is also neither. Next, I would like you to answer a few questions on what we just did. So go ahead, pause it now, answer those questions, and then you can check your answers when you're ready. If you answered the first question that said, will any linear graph have a maximum or minimum point, why or why not? So linear graphs are like our graph in letter A, our straight lines. And the answer to that should have been no, because they are never going to change direction. They're never going to go from increasing to decreasing or decreasing to increasing. So our linear equations will never have a maximum or a minimum point. For question number 2, will any exponential graph have a maximum or minimum point? Why or why not? And that's looking at the graph from letter C, and that answer is also no, because they never change direction either. So your exponential functions are either all increasing or they're all decreasing, depending on whether it's growth or decay. So they will never have a maximum or minimum point. And then finally, question number 3, how can you tell if a quadratic graph will have a maximum point or a minimum point, and what is the point called? So our quadratics are the only graph or the only function we have learned about this year that has a maximum or minimum point. So if the graph opens up, it's going to have a minimum point, and if the graph opens down, it will have a maximum point. So let's just draw a quick little picture. If it's opening up, we have a parabola that looks like this, and that point right there, which is called the vertex, is going to be that minimum point. And if it opens down, we have our maximum point, which is on the top. Again, that point is going to be the vertex. If you have questions on this, let me know.